Okay, so first thing we need to do is we want to duplicate our little cylinder here. Let's duplicate this over, and I'm going to name this one here 4_rim lighting. Alright, let's go ahead and duplicate our specular 4_rim. Oh, that was D, I want 4. And I'm going to do the same for the material. I'll just assign that to the model. And let's open up this shader. Now, as we've done in previous lessons, we're going to start from scratch. So I'm just going to remove all of that, and let's start again. Alright, so we'll create our shader. This one here we're going to call Unity Cookie /doot /beginner /4-rim lighting. Alright, let's add in some properties. So which properties do we want for this model? Well, we're going to want the colour, of course. I'll just call this one here colour. The type of colour equals a default value of 1.0, 1.0, 1.0, 1.0. Alright, let's do the same for our spec colour. Specular colour equals 1.0, 1.0, 1.0. Alright, and for our specularity we need our shininess. This one here is going to be a float with a default range of 10. Okay, so this is everything we've already done previously. But what we want to do now is add in some controls for our rim lighting. For that we want to have a rim colour and a rim range. So this one here, rim colour. And this will just allow us to tint the colour. Colour equals 1111. And finally the rim power. So the rim power we will use as an exponential range so that we can make it a really nice sharp rim or a very subtle rim. Rim power. This one here will be a range between 0.1 and 10. Now the reason we do 0.1 and not 0 is that the power function does not like dealing with the value 0. It just doesn't, it mathematically can work, but it just doesn't like it. It's similar to how shaders will act very weird if you divide by 0. Let's add our subshader. Within this we want to have a pass. We want to have our tags. Light mode equals board base. Just like previously, that one there makes it work. CG program and NCG. Alright, so let's start off with our pragmas. Vertex vert and fragment frag. So that's all things we've done previously. And what we need to do next is we need to create our user-defined variables. So these ones here, we're just going to have do a uniform for each of these. Float for color, uniform, float for spec color, uniform, float for rim color, uniform float, shininess, uniform float, rim power. Alright, that's great. So let's go ahead and do our Unity defined variables. Alright, so in here we'll go uniform, float for light color 0. One day I'm sure they'll put that as a predefined variable, but they decided not to do that in Unity 4, so we'll leave it like that. Base input structs. Okay, so we want to have our vertex input and our vertex output. Okay, so what information do we need? Just with the specular one, we need the float for vertex and the normal. 3 normal. Alright, that's great. For our output, we want to have a float for boss, which is required. This one here is going to be SV position. We have the float for boss world, and this will be text code 0. Float 3 normal dir, text code 1. So we're just overriding those text coordinates because we don't need them anymore. Alright, so let's go into the vertex function. Vertex output is the one we're writing to, and the function is called vert. Vertex input is our base, and we're assigning that to V. Alright, vertex output O, we're assigning our output to O, and we're going to return O. And make sure that you have your semicolons. As a Python programmer, I always forget them. Alright, so we're going to start out with O.pos equals mul, and we're going to multiply the unity matrix MVP by the v.vertex. That one there is required on all shaders. Pos world is going to be a similar thing. We are going to multiply the object to world with v.vertex. And that will allow us to work with the vertex data in the fragment function. Moving down, we want to output our normal direction. And I forgot an equal sign there. Okay, so this one here, we want to have this normalized. And within here, we want to null the v.normal against the world object. Now, because world object is a float 4x4, we want to make sure this is a float 4. And after the null, we're just going to go .xyz, because we don't need the fourth component. We're going to need that fourth component just to multiply with the world object. Right, that's fantastic. So that is our vertex function done. We're motoring through these now. Notice as we start to understand this, we can actually write shaders a lot faster, and we get to write them a lot easier. So you can see this time I'm writing it from top to bottom, creating the functions. This is how I normally like to write my shaders, rather than making the structure and then filling it out. And it is a way that you'll probably get used to once you have written a fair number of shaders. Okay, so our fragment function, this one here is going to be a float4 frag, which is the name of the function, vertex output as the base, and we're going to assign that to I. And we'll give this one here the semantic of color. What do we need to do? First thing we need to do is set up our main lighting that we had before. So float3 normal direction equals I dot normal dir. Nice and easy. Float3 view direction. Now this one here, we're going to make sure that we normalize this, and this is going to be world space camera position dot xyz minus this is going to be I dot pos world dot xyz. Okay, float3 light direction. This equals normalize, and we're just going to normalize the world space light pos 0 dot xyz. Okay, that's great. Let's go float in. Attenuation equals 1.0, and now let's calculate our lighting. Right, so start with a diffuse. Float3 diffuse reflection. Attenuation times the light color times the saturate. Right, and we're going to saturate the dot product. There's a couple of spaces here. I find it easier to read if there's a couple of spaces in between each function. Right, dot product of the normal direction and the light direction. Okay, now notice I've used a saturate instead of a dot this time. That's fine, you can use either or. Saturate will just truncate between 0 and 1, whereas max function will just trim off anything less. So it's up to you which one you use. I tend to alternate between them. They both work. They're both fairly on par in performance, so whichever one you like to use. Right, so let's create the specular reflection. Right, so the specular reflection, this one here, we want to have attenuation times the light color 0. This one here, I'm just going to make sure I go .xyz, because these are float 4s or float 3s. The light color is a float 4. You can also use RGB. I think I've mentioned this earlier on in this series. You can use RGB or XYZ, or you can even do something like RRB if you want to replace the green channel with the red channel as well. But you cannot go XGB, or you can't mix between them. So I find it better to keep to XYZ for consistency. It's up to you. The light color, we need to calculate our specular reflection. We'll do this by first take this one here, copy and paste, because we only use that as a mask, remember? Right, and now we'll multiply this by the power, and within this power we're going to take the specular to the power of shininess. Okay, and in here we are going to reflect negative light direction, normal direction, and we need to take the dot product of this one against the view direction. Okay, alright, now that we've done that, we also want to saturate this one, I believe. No word wrap on, I must have turned it off. Okay, so saturate, you need to saturate the dot product, which is going to end here. Now if you're not sure where it ends, just put your cursor or select one of these little brackets, and you'll notice you probably can't see it on the screen. It's very hard for even me to see you looking at my screen. Is that this one over here is been just grayed out. Which one's been grayed? This one's been grayed out. There we go. So it will put them over. There we go. Dot product there, and then saturate comes to there. So there's a little bit of a grey box around it if you're using monodevelop. I wish it was a bit darker. I believe you can change that in your settings, but I haven't got around to doing that. Okay, so that's our specular reflection. So now it comes to calculate our rim lighting. Alright, so for the rim lighting, float rim equals, and we want to go 1 minus saturate. Actually, before we do this, I'm going to actually show you each step of the process, just to give you an idea of how things are working. So we go light final, right, so we'll just multiply by that, 3 light final equals rim lighting. Right, so let's just call this one here rim lighting for now. Do the first line of it, and what we want to do is do the dot product of U direction and normal direction. Alright, let's come in here and reload this, and it'll probably break. Nope, maybe not. Alright, so let's go ahead and select that. For rim lighting. Okay, so it's, we haven't placed in this rim power yet, but you can see how it is dark at the end and then white in the middle. So if I just make this rim color, we haven't actually plugged in the rim color either yet. We haven't plugged in anything yet, but you can kind of see how that's working, how it fades off towards the edges there, and that's based on our view direction. Alright, that's great. Okay, so we also want to normalize our view direction, and we'll refresh that, and you probably can't see it on your monitor, but there's a slight change. It's a little bit softer. After this dot product, what we want to do is we want to saturate this. Let's go 1 minus. Now we can see this change. There we go. Oh, look at that. Beautiful. So it's white around the edges and not in the middle. So this isn't our rim that we're viewing right now. We're going to be working with this in a sec. What we're going to do now is go float 3, and this one is going to be called rim lighting. I'm just going to call this one here rim lighting. And for this we're going to go ahead and take the dot product of the normal direction and the light direction. Right, so there is our little Lambert shader once again. Now to make sure that there's no values on the back, I'm going to saturate this. Alright, so we want to times this by the power of rim to rim power. Cool, there we go. Alright, so our rim power will now affect it, and we only get it on the direction of the light. So if we're looking straight from the light view, we can see around the edges, you can see it from the light over there. It just gives it a really nice rim. So what's next is we need to tint this. So I'm going to tint this by going times underscore rim color times, actually let's put this on the front, put this before any of the calculations there, and go continuation times light color O.xyz times rim color times that. Alright, so the reason we keep this light color 0 in here means that it will be affected by the color of the light and the attenuation, and also means that if the light is not if the light is off, we won't still see that light, so it'll react to that. Okay, so let's come back into Unity, and we can see that affected there. So we can actually now change the color of this light, and it will affect the rim. Just like we can come in and we can change this rim color, and we can also affect it. And you can actually use the two to cancel out if you like, or just make one black. And there you go. Alright, that's fantastic. It's almost done now. So what we're going to do now is we're going to go rim lighting plus, and we're going to add in the diffuse reflection plus specular reflection. Alright, that's great. And also we need to have a fallback while I'm here. Alright, so fallback. Alright, you can use diffuse, specular, whatever you like in here. This is a specular shader, so I'm just going to use specular. Alright, let's load that in, and that's great. So if I select that rim now, we can adjust the rim power to make quite intense. We can tint it if you want, and you can see that rim showing up there. Alright, so this doesn't look overly helpful just on this flat white shader. We colour this here like a darker colour, or like a blue or something, probably see a little stronger. There we go. Alright, so that's fantastic. Let's just come up and reset this to default settings. Alright, so our shader's looking pretty good. Oh, there's one thing that we've forgotten. You can see that these are all light on the back side, this one isn't. I have forgotten to come in here and go add in our ambient light, which is Unity light model ambient, I think. I always forget which way around that goes. See if it works. Yes, it does. Sweet. Alright, so that is our rim lit shader absolutely done. Hope you guys enjoyed this. Let's stay tuned for the next one when we start getting into some really cool stuff that is very beneficial, and once we've finished up all that, we can get onto textures.